Hey, boys and girls, it's Mr. Mac. Today we are going to do Module 2, Lesson 4, which is using partial quotients. So let's break that down just to understand what that means. Partial, parts, quotients are answers to division problems. So we are going to find our answers to these division problems by breaking the problem down into little parts. So in the I can statement, it says I can use partial quotients to divide a multi-digit number by a two-digit divisor. So Team Mudfooters is participating in an obstacle course marathon. For each obstacle the team completes, $99 is added to their prize bank. The team completes 12 obstacles. If each team member takes home $66, how many members are on the team? So first thing is we got to find out before we do any division, we got to find out how much total money they've earned, right? So that would be 99 times 12. So we would set that up as 99 times 12. Now, I'm not going to take the time to solve this problem right now with all the steps, okay? But I know that 99 times 12 is 1,188, right? So then in this problem, I have 1,188, and that is going to be divided by 66. So I have 1,188 divided by 66. So we've done long division where we've done 66 dividing into this number. The new strategy would be partial products, where we're using facts that we know to solve this problem a little bit differently. So we've worked on multiplying by powers of 10, so 10, 100, 1,000, and so on and so forth, and multiples of 10, 10, 20, 30, 40, 50, 60, 70, 80. They should be quick for us to multiply by. So if I was going to multiply 66 by 100, okay, that would be 66 times 100 would be 6600. Now that I can't subtract from this, right? So that's definitely not going to be what I'm going to do. But I could do by 10. So what is 66 times 10? Well, let's see. 66 times 10 is 660. So when I subtract this 660 from this problem, I get an 8, I get a 2, I get a 5. Okay, so now can I do another 10? If I did 10 more, that would be 660. I can't do 660. So now we're going to try a number that's smaller than that. So if I tried, they're pretty close to each other, but they're not right next to each other. So I might try 66 times 5, which is a nice and easy way for us to do division because we know our 5's times tables. 5 times 6 is 30. 5 times 6 is 30 plus 3 is 33. Okay, so I might say, all right, if I did 5 more, that would be 330. I subtract, I get an 8, 4, 1, 12 minus 3 is 9, and then 4 minus 3 is 1. So now, again, I had 10 and I had 5, so I need to see how many 66s can go into 198. Well, it's definitely not going to be just 4, so I'm going to try 3 and do 66 times 3. That gives me 18, carry my 1. 6 times 3 is 18 plus 1 is 19. I get 198. So I know that this 3 here is going to give me 198. And I subtract and I get a 0. So the question is, well, how do I have an answer? Well, you take 10, 5, and 3 and you add them all up, and that's going to be your answer, which is going to be 18. All right, so this is how partial quotients works. You're taking parts and just chipping away at the total to try and find out your answer, which to this problem would be 18. Okay. So if we're going to go on to the next slide and try another example, because these can definitely be a little bit challenging. I want to do a couple examples here. All right. It says another team adds $594 to their prize bank. If each team member takes home $54, how many members are on the team? Okay, so we have 594, and we're going to divide that again by 54. Now, I always like to start with tens in these problems because that way I can do a very clean multiplication fact, right? So if I do 10, 54 times 10 would be 540. All right, so when I subtract that, I get, luckily, just 54. So then 54 goes into 54 one time. So when I subtract that as well, I get 0. So my answer for this problem would be 11. All right, so 11 members in the team for this example on example number 1. All right. So looking at the steps that were given here, what equation can you write to model the number of team members? So 594 divided by 54 is what we did there. Okay. About how many team members complete the obstacle course. So about. So if you're talking about estimating, okay, we did estimating where it was, okay, what is close to 59 that can be divided by 54? We did this before. Okay. So 54 is close to 54. So if I change that to 540 divided by 54, okay, then my answer would be 10 because 54 divided by 54 is 1, and then add on the 0 to get me 10, which again, our answer is a reasonable answer. Then it says, what number is the divisor and what number is the dividend? Well, here is our dividend, 594. All right, and 54 is going to be our divisor. Then it says use your estimate. What multiple of the divisor can be subtracted? So again, we did tens here, absolutely tens, because our estimate was a 10. So that was really good for us to understand that. I always like to start with 10, or if it's a really big number, 100 or 1,000, and try and remove as many of those as we can. All right, so this was another example with that. I'm going to do one more example just to make sure that we are ready to go. Okay, so here's another example. It says there are about 1,932 calories in a 14-pound watermelon. How many calories are there in 1 pound of watermelon? So again, 1,932 divided by 14. All right, so now here's one of those problems where if I just did 10, that would give me 140, which is way far away. So now I'm going to multiply it by the 100. So 14 times 100 is 1,400 because it's a 14 with 2 zeros. Okay, I'm going to subtract, and then I have 532. Now I might start taking away some of those tens. So if I did 10, I would subtract the 140. Okay, and you would get 2, 9, and a 3. And we could continue on with that. Now, you might be able to multiply 14 by 20. Okay, you may or may not. If you could, you are able to do that. So 14 times 2 is 28. Add on the 0. So I might say, all right, let's try 20 and subtract 280. Okay, it doesn't always have to be just 10. It can be multiples of 10. 9 minus 8 is 1, and then 3 minus 2 is 1. So now I have 112, and I can't do 10. So now's the time when I'm going to try and get as close as I can without going over. So I might say, well, let's see what 14 times 8 is, because they're so far away. 8 times 4 is 32. 8 times 1 is 8, plus 3 is 11, and that would be exactly the answer. It would be 8. So then I'd get 112. I would subtract and I would get a 0. So then when I add up all of these to get my answer, I would have 138 as my answer for that problem. So the biggest takeaway from this last example, guys, is it doesn't always have to just be tens, hundreds, and everything. You can do 20s and 30s as long as you're comfortable with multiplying by the multiples of 10. If you're not, it's going to take you a little bit longer because in this problem, we would have to take away 10, take away 10, take away 10, and then we would be down to the taking away the 8. So the better you are with multiplying your multiples of 10, guys, the faster and more enjoyable these problems are going to be. All right. Hope these examples help you. Best of luck with your lessons. Take care, guys.